Today is going to be all about building functions out of other functions. So we're starting off with some basic function arithmetic, just adding, subtracting, multiplying, and dividing. To me, the notation is pretty straightforward for this. So I had a couple functions up here. I asked you to do addition, subtraction, multiplication, and division with each of them, find the domain for each. So thank you for tackling that. I'm going to put my solutions up here and give you a chance to check those and ask some questions. I'm losing the half a point right here, aren't I? Yeah, sorry guys, sorry. I'm not getting 100% on this assignment. Yeah, and we are going to be, I'm glad you guys are making note of the domain restriction here. We are going to be dealing with domain today. So all that stuff from chapter 2, or not chapter 2, section 2, we're going to be utilizing that. Do you guys remember our 2 things that we got to look for when we're dealing with domain? What are we looking for? Fractions and radicals. The bottom of a fraction, what's our restriction? Not equal 0, and inside of a radical is greater than or equal to 0, right? Remembering those? Because we're going to see those pop up again today. All right, so these are usually the pretty straightforward ones, but I'll entertain questions now. Yes, thank you. Oh, good for you. You did polynomial long division and you got 2 plus something over x minus 2. That's awesome. Good for you. So you've created a different version of that. I wouldn't say that that's more simplified than this one. I'd say this is far enough for you, but I'm glad that you took the time to do that. Got a little practice. When we get in chapter 2, when we start talking about oblique asymptotes for rational functions, you're going to be like right on it and ready to go with that. So yeah, it's going to be awesome. You'll love it, and you're gonna you're doing the extra practice, so that's good. So yeah, this one I'd say that's simplified as far as it's going to go. Yeah, nonlinear asymptotes. We'll have like quadratic asymptotes. They're pretty fun. All right, we feeling okay about the basic adding, subtracting, multiplying, and dividing. You're just taking these 2 things and putting a symbol in between and simplifying it, basically. Now, the ones that my students I usually aren't so confident with, at least at first, is composition. So that's what we're going to do next. Compositions like the FOG or f of g of x, g of f of x. That's usually the reaction I get. Oh man, I hated these. So that's okay. We're going to make you this time around. It's the second time that you've seen this, and this time around you're going to be like, you know what? That was not that big of a deal. It's okay. Do you have to write all that stuff down? No, let me talk about this and you'll decide what you want to do with this. But these are 2 different ways to write it. I actually much prefer it this way instead of the FOG. In fact, if I'm ever doing an assignment and it says this, I'll turn it into this because it just makes more sense to me. But the thing you need to know is that this is basically what we're doing is we're taking 2 machines. You can think of a function as a machine. You stick something into it and something else comes out. We're taking 2 machines and we're hooking them together is basically all we're doing here. We're going to take x is going to go into one of the machines, and then the output's going to spit out of that and go into the other machine, and then we're going to get a general output from that. Okay, so this is kind of like, this is just like it's like a factory that's got 2 different machines inside of the factory. Your cows come in one side of the factory, and they go into the first machine, and that turns them into hamburger, and then the hamburger goes into the second machine, and that turns them into Big Macs, and then the Big Mac comes out the other side of the factory. Yeah, it gets really interesting about that analogy when we start talking about inverses, and you stick a hamburger into a machine and get a cow out of the other side. Yeah. But here's the thing I need you to know, and if you can kind of remember this, and you might even add this to your notes, when we're doing these, especially in this notation, it kind of works inside out. The x is going into the G machine first. Can you kind of see that, how the X is inside of the G thing? And then the G machine's output is going to go into the F machine. So if I were to sketch it out, F of G of X, the X is actually going into the G first and then into the F. And when we do this, we're just going to work from the inside out. This is not multiplication, this is composing. So there is no multiplication inherently going on here. There might be multiplication inside one of those functions, but this is not a time symbol. This is a composition. It's a little o. It's a little o. And then you put it, yes. And we're going to practice with that. So the big thing, if you're feeling a little apprehensive about this, just remember, this is just really messy substitution. That's all this is really messy substitution. And sometimes it's not even that messy. There is one little trick to it. I'm going to illustrate that with our first set of examples. So let's get into our example here. Does anybody need a moment, or are we good to go? Another 2 seconds. Give me a thumbs up when you're ready to go. Well, it gets messy. So people get apprehensive about it because it does get messy, and sometimes it's just like it's like that notation thing. It's just the translation piece gets a little bit messy. So here we go. I'm going to give you an example, a couple of functions, and we're going to do 4 different things with it. So here's our 2 functions. We got f of x. I'm going to define as the square root of the quantity x plus 1. And g of x, we will define as x squared plus 4. And we're going to do several things with this. I'm going to show you that it's really just a whole bunch of substitution. So our first order of business is we are going to do f of g of negative 2. And the key to this, and I'm going to put this on my page, you may have already written this down, but we want to work from the inside out. So when we look at this thing, this f of g of negative 2, my question is, what is the innermost thing that you see in that? I see a negative 2 as the innermost thing, but there's nothing really to do with negative 2. What's the innermost thing that you can actually do something with? G of negative 2. And you guys know what G of negative, you know how to find G of negative 2. So off to the side here, I'm going to do a little side work. Let's write down what G of negative 2 is. You knew how to do this way back in Algebra 1. You learn that, well, we're just going to take that negative 2 and we're going to pop it into our G function. The G function was x squared plus 4. We'll just put that negative 2 in there, do a little bit of mental math, and I believe we're going to get 8. Does that sound right to you guys? So let's replace the G of negative 2 with 8. And we're just substituting here. G of negative 2 is 8, so put 8 in place of it. And now we're left with f of 8. And again, you know what to do with f of 8. So we're going to take our f function this time. We're going to pop that 8 in there. And bada bing, bada boom. That's square root of 9. That's 3. That's it. We stuck negative 2 into this composed function. We got 3 out. Worked from the inside out, not too bad. We feeling okay so far? Questions? Right. All right. I like your idea. Let's do that. Let's do g of f of negative 2. Could you guys try this one for me? See if you can do this one on your own. Same idea. Start. Yep. Do you need someone to walk down with you? You're all right. Okay. We got f of -2. So I'm going to do a little side work here. We'll figure out what f of -2 is. Now we are in the realm of real functions here. So if we end up with imaginary complex answers, we're just going to go ahead and say that f of -2 is undefined. So so we're done. Yeah, we can't do any more. So our final answer then is that g of f of -2 is also undefined. So we had this really fancy factory we put together where we hooked f and g together. We tried to put a -2 into it. We broke the first machine that went into it. We put an ingredient into it that it couldn't handle. So we stopped. We broke it. Question. We're not going to be, when we're dealing with functions in this first chapter, we're not doing complex imaginary numbers. Okay. Could you do it though? Yeah, but we're not doing it. You guys are gonna have so much experience with imaginary and complex numbers in this class. Be patient. We will get there. You're gonna love it too. But for right now, let's just keep it simple. Yes. The answer ends up being 3. I think that's a coincidence. Okay. The question was, so if we did, hey guys, please, this is a really good question. Hey, don't miss this. If I gave you another function, let's say that didn't, okay, this is a different problem. If I gave you another function, let's say you did f of g of 5 and you got the answer 8. Your question is kind of, if I reverse it and do g of f of 8, am I always going to end up getting back 5? Is that what you're saying? Oh, if we do g of f of 5, are we also going to get 8? And the answer is no. Now, you could come up with some functions where that might happen, but that would just be coincidence. Yeah. But we are not dealing with imaginary numbers and functions, right? Because domain, right? The inside of a radical must be greater than or equal to 0. That's why we're doing that. Stay away from those. All right, here we go. Now we get to do the fun part. So we've done some specific examples where we're actually putting inputs into this. Let's go ahead and do the general case, f of g of x. And this is, I think, where most people, like when I heard all those moans and groans a minute ago, I think this is probably what you're remembering. But again, I want to remind you that all we're doing here is just kind of some messy substitution. I need to copy my functions down so I can get them on the screen here at the same time. Give me just a moment. If you remember how to do this, go for it. So we want to work from the inside out. So what's the innermost thing you see here? That's the x. Can't do anything with that, but I do see a g of x. And g of x, we've got something we can replace g of x with. G of x is x squared plus 4. So go ahead and do that substitution. We're not substituting an actual number in like we did last time, but we can substitute in an expression. And the way you handle this is the same way that you handle it if I'd asked you to find f of 3. You're just going to take your f function and you're going to plug in x squared plus 4. Now, this is where it gets a little messy. And this is where I personally find it a lot easier to break this into chunks. So I'm going to write out my f function first, leaving out my x's. My f function is the square root of x plus 1. I'm going to double check and make sure that that is the correct f function. It sure is. And then in a separate step, I'll go through and fill in the details. If I try to just put that stuff in there all at once, I'm going to end up starting to make some mistakes. And we'll simplify that out. Those parentheses aren't really doing anything. So we've got x squared plus 5. So f of g of x is x squared plus 5. That's as good as we're going to get. So I am so glad you asked that question, because this is one of the most common mistakes in all of mathematics. You see this all the way up into multivariable calculus. You cannot distribute an exponent, and remember, a root is just an exponent, right? A square root is like an exponent of a half, and exponents do not distribute. This is not equal to x plus root 5. It is not. I wish it was. There are so many things in math that would be way, way easier if it was, but it's not. Right? You learned back in Algebra 1, how many people made this mistake a million times in Algebra 1, maybe even Algebra 2? If you had x plus 3 and you square it, is that equal to just x squared plus 9? No. It's x squared plus 6x plus 9. You would need to write out x plus 3 twice and do FOIL, or there's some shortcuts to it. But it's not just an x squared and a 9. You got to do the OI, the O outside inside of the FOIL. Okay. So no, you can't distribute. Thank you for asking that question. And that's it for that. Questions on this one? Yes. Root x squared plus root 5 is not correct. No, you cannot split up a radical that has pluses or minuses in it. Okay, now this does work. This is not the same, but if I had the square root of 5x squared, that is the square root of 5 times the square root of x squared, and then we could do a little bit of simplifying. So if it's a multiplication, then we can split it up into multiple radicals. Okay, but not with there's a plus in there. So that's done. Okay. We found it. Tell me about the domain of this function. No domain. There's not a single x that I'm allowed to put into this. So, hey, we've got way too many side conversations going on. Please stop. Please stop. Pay attention. Let's do the work. You guys learned how to do this back in 1.2. The thing inside of the radical x squared plus 5, go ahead and write that down, x squared plus 5. What is the restriction for anything inside of a radical? We're talking domain. Greater than or equal to 0. What is the solution to that inequality? What are you allowed to, what values of x would make this true? Everything would make this true. I would say everything would make this true. You could subtract 5 from both sides. X squared is greater than or equal to -5. Isn't this always going to be positive or 0? So isn't it always going to be greater than or equal to -5? So I'd say that the domain, that the solution to this, and therefore the domain, is all real numbers. I'm not sure how absolute value would come in. So that, yeah, kind of, because the x squared is forces things to be positive like an absolute value does. Yeah, I see that connection. Sure. All right, one more thing, and there's a big connection I'm hoping you guys see here. Spoiler alert, sorry. Anybody want to guess what we're going to do for the last one? You got it. You should be teaching this class. You're like one step ahead of me. Find me g of f of x. So see what you can do here. See if you can do this one on your own. So what does this say to do? Well, let's do a little substitution first. What is f of x? F of x is the square root of x plus 1. So let's replace f of x with the square root of x plus 1. All right, we've simplified it a little bit, and then we know what to do now. We need to take the g function and plug that in. Let me write down my g function first. Leave a nice space. And then we're going to plug that square root of x plus 1 in there. And then we'll simplify it. Square root and square cross out. Yeah. And final answer is x plus 5. Question before we move on?
To give us the problem like this on a test, would you want us to do the rewriting of g of f of x into g of x plus?
Yes, I want to see these. I want to see these steps. If I ask you to show work, I want to see the steps. Okay, for two reasons. One, if you write this down, you're much less likely to make a mistake. The common mistake is putting the wrong function into the wrong function. And it happens all the time, and it's really easy to do. So if you actually substitute what f of x is into there, you have a much less of a chance of doing that. Two, I need to see your thought process. Okay. Please don't miss this. Okay, please don't miss this. So what is the domain of g of f of x? You think it's all real numbers? Okay. Okay. So what you're telling me, hey, can you guys please not miss this? Thank you. What you're telling me is that I can plug any number I want into g of f of x, and I am going to get an output from it. Any number at all, I can plug into g of f of x, and I will get an output. Any number at all. Can somebody give me a counterexample that you have written down on your page to that statement? What can you tell me? What number have we already plugged into g of f of x in this same problem? We plugged in -2. Did we get an output when we plugged in -2? So we got a problem here, folks. So what I've shown you so far is like the bulk of the work. Remember I told you this is really straightforward, simple substitution, except there's one kind of little tricky thing. This is the tricky thing. What we got to remember is that when we're doing this, we're taking that input. Don't forget like the big picture here. We're taking an input and we're running it through two different functions, okay? If we break either one of these, then the whole factory doesn't work, correct? So when we're talking about the domain for composite functions, it's not enough to just look at the final output. We also have to look at the individual pieces. We got to keep in mind that whatever we put into this is going to go into our f function first and then into our g function. So when we're talking about the domain, we can't just look at the final output. We look at the final output in its domain, but we also have to be conscious of the domain of the inner piece. Give me a second, please, and then I'll answer your question. Okay, so this is not correct. The domain of this is -infinity to infinity, but we have to think about the domain of f of x. What is the domain of f of x? Let me get it back on the screen here. So let's do the work here. Inside of f of x, we got a square root. X plus 1 is inside that square root. The restriction on the inside of a square root is that it must be greater than or equal to infinity. We do a little bit of algebra. We got x greater than or equal to -1. So the domain of the overall composed function, yes, this has a domain of all real numbers, but we also have to include this. So we combine those two things together, and this is going to win us. So our domain for our overall function is -1 to infinity, which is why -2 didn't work, right? We tried -2, we got undefined because it's not part of the domain of the overall function. So we're going to do another example from start to finish, and we're going to keep that thing in mind, and then we'll be done. Okay. Question before you move on. Yes, that's what it is. Yep. Okay. Let's do one more. How are we doing for time? That's good. That's awesome. You guys are doing great. So what did we just learn? We should probably write this down. Domain of composed functions. When we say composed functions, we're talking about like f of x, f of g of x, and g of f of x. So what I need you to know is that the domain of f of g of x only includes values also in the domain of g of x. So you've got to look at that inner function. Remember, whatever you plug into this factory, f of g of x is just a factory with a couple machines in it. Whatever you send into the factory has to go through the individual machines too. So we got to make sure that when we put this x into the g machine, it's not going to break it. Now, a lot of times this doesn't end up making a difference, but sometimes it does. So we'll look at a couple examples here. So first example, let me give you a couple other functions. F of x is x squared minus 3. And g of x is 1 over x plus 1. So if we're going to find f of g of x and g of f of x, we're going to find the domain of each. Yeah. Do you need someone to go with you? Yeah, thank you. Okay. So knowing that we're going to have to find the domain, before we get too far into it, we're going to even start thinking about it. So let's do f of g of x first. And before we even get started, let's start thinking about the domain of g of x. So I want you guys to write out the steps for this, okay? So what do we see in g of x that could be a problem? Well, it has a denominator. So x plus 1, the restriction is the denominator cannot be equal to 0, which means x can't equal -1. So we're going to keep in mind that no matter what, even if -1 is part of the domain of what we get out of this, we're still going to exclude it because it would break the G machine that's inside of our factory. So now let's go ahead and do it. F of G of X. So let's just do a little substitution. What can we put in place of G of X? 1 over x plus 1. And then we can do that. F of that, well, that's just my F function with a pretty big old messy thing plugged into it. My x function is x squared minus 3. And what am I sticking in there? I'm putting a 1 over x plus 1 in there. And we can simplify this a little bit. We could square the top. 1 squared is just 1. We could. I'm not gonna multiply it out. I'm just gonna leave it as x plus 1 squared. It would be x squared plus 2x plus 1. Good for you. I'm going to leave it like that because that's good enough. And it's easier for me to find the domain for this function. Let's do the work. We've got a denominator. That denominator is x plus 1 squared. And what's the restriction on our denominator? Not equal to 0. Let's square both sides and solve. We get x is not equal to -1. So now this time, did it matter whether we dealt with that other domain at the beginning? It didn't really, because it ended up, that -1 that we excluded from this ended up being excluded from this anyways. And a lot of times that's going to be the case. Sometimes you're going to find stuff that's not. Okay, let's do this backwards. So yeah, so I'm sorry. So our final domain would be, thank you, -infinity to -1 and -1 to infinity. Go ahead and try this backwards. 2g of f of x. Again, look at the f of x and see if there's anything that we need to worry about restriction-wise there. For f of x, do we need to restrict anything? No, so the domain here is already all real numbers. I'm going to cheat and just write all real numbers. This is not our final answer, so it's just work. The domain here is all real numbers, so we're not going to need to worry about it. We don't need to add anything extra in, so that's good. But let's practice. Go ahead and do the substitution. So we can replace f of x with what f of x is, x squared minus 3. And then we can put that into our g function. Is this feeling a little bit better this year than it did last year? It's just substitution, right? It's just kind of messy substitution. Little simplification. That doesn't factor, does it? Well, let's go ahead and our restriction. Well, we got a problem area, potential problem area. It has a denominator. That denominator needs to be not equal to 0. We'll solve this equation. We got x squared not equal to 2. Take a square root on both sides. Don't forget your plus or minus. So this domain is going to be kind of a messy one. We need to exclude positive and negative too. Final domain starts at negative infinity. I'm not sketching it. Are you guys okay with me not sketching it? And then where's the first break we're going to hit? Negative root 2. And then it picks up a negative root 2, and then it goes all the way up to positive root 2. And then it breaks up on the other side and goes up to infinity. All right. I want to show you one more quick example. You're going to see some problems like this in the book, and people are going to have questions. So I just want to answer the question now. Any questions on this example that we just did together? Feeling all right? All right. Right as this is an example, you're going to see a whole section in your assignment on these, and people kind of freak out when they see them. Right as a composition of functions. F of g of x. Okay, we'll do a couple of these. They're really easy. They're really easy. Okay, so here's an example. They're gonna say something like y equals x minus 7 cubed, and your job is to write this as a composition of functions. And it's not. I get that it's not super clear what they're asking you to do here. That's why I want to go over this. So essentially, you're going to say, okay, well, that means that f of g of x is x minus 7 cubed. All right. But you also need to tell me what's f of x and g of x. So think about this for a second. Hang on. I'm not looking for an answer right now. I'm looking for you guys to think about, okay, what is kind of the main function that's going on in here? And what's the part that's on the inside? The main function is, I'd say the main function is like a cube, right? That's the main function. Now, f is on the outside, so f is the main function. So I would say my main function is x cubed, right? That's kind of my outermost function. And then what's going on the inside of my x cubed? I got x minus 7. If I plugged x minus 7 in for x right here, would I get that same thing? Yeah, that's it. That's it. That's it. And we're done. We're done. We're finished with the problem. You're just separating it. Yeah. You're figuring out what's on the outside, what's on the inside. Here, let me give you another one. Y equals 3 times the sine of x over 2. Oh my gosh, this looks so hard. So we need to figure out what's our f of x and what's our g of x. And this is going to be f of g of x. Why don't we just write it as f of g of x? F of g of x is 3 times the sine of x over 2. So we need to figure out what's getting plugged into what. The g is the thing that's getting plugged in. What does it look like is going on inside of this? X over 2, I agree. X over 2 has been plugged into what? 3 sine x. So if I took this x out and replaced it with x over 2, this is exactly what I would get, right? That's it. That's all they're asking you to do. They want you to try and get an idea for what's on the outside and what's kind of being pushed into it. Does that sound pretty easy? Yeah, you guys got this. I'll go ahead and put the assignment up on the board. You guys can get started on it. You guys did awesome today. Thank you.